Okay, now let's look at translation vectors. Translation vectors. A translation vector joins 2 points, none of which is the origin. Now, remember when we had position vectors, they were starting from the origin. When you have a translation vector, it really doesn't start at the origin. It starts from another point that is not the origin. So the translation vectors typically do not start with an O. So A, B, B, C, C, F, these are vectors which do not involve the origin, so they are what we can classify as translation vectors, right? You can calculate translation vector from position vectors, right? And this is the standard formula for doing that. If ever I'm asked to find the vector AB, if I know OB and I know OA, right? If I know OA and I know OB, the practice is that I take the second one, this one, OB is vector, and subtract the first one, OA, right? That's the practice, right? If I had PQ, right, I'll take the second one here, OQ, right, and subtract the first one there, OP. So that is the standard practice. When you're given position vectors, you can use position vectors to find a translation vector that translates between those 2 points. So here's a practical example here. OP is 3, 2, OR is minus 2, 2, OX is 2 minus 3. When you're asked to find PR, it's simply OR. Remember, you start with the second one, minus the first one, OP, right? OR minus OP, right? Which gives you minus 2, 2, minus 3, 2, which gives you minus 5, 0. Okay? Px will be, I take the second one, OX minus OP. This will give you, OX is 2 minus 3, and then your OP is going to be 3, 2. So that's going to give us minus 1, minus 5. And there you have it. Rx, we start with the second one, OX minus the first one, OR. So this is going to give us OX is 2 minus 3 minus OR, which is minus 2, 2. So this is going to give you 2 minus a minus 2 minus a minus is a plus. 2 plus 2, 4. Minus 3 minus 2, that's a minus 5. So simple calculation there, right? So just remember, you take the second one, the position vector of the second point minus the position vector of the first point. Now, we have other situations that do not involve position vectors whatsoever. So for example, here we have the vector AB, right? And we have the vector BC, and we're asked to find AC, right? So if we had position vectors, we would have said OC minus OA, right? But we don't have OC in our information, and we don't have OA, so this is invalid. It doesn't apply. So what do? We use our reasoning. We want to move from point A to point C. We can do it in stages. We can move from point A and then get to B. When we're now at B, we move from point B and get to C. So AC can be found by adding AB plus BC. Remember, this is a journey. A vector just describes movement from one point to another. So if I'm able to move from A to B and I'm able to move from B to C, I just add those two vectors and then I will have effectively moved from A and end up at C, but I did it in 2 steps. So AB is 2, 3. BC is 4, 6. You add these up, you get 2 plus 4, 6, 3 plus 6, you get a 9. So that's how simple that is.